Hello, I'm Shay Morris with Triton Technical Services. In this video, we're going to review a job we recently performed with Hydrotide. The customer had an extrusion press that was suffering from corrosion in excess of 1/4 inch. The repair required machining new support surfaces using portable milling machines. This mock-up is a representation of that press. The features we are going to be concerned with are 4 pin bores, which drive the alignment of our laser tracker to the press, and also this member here, which represents one of 4 columns on the press, 2 upper and 2 lower. We have broken the job into 3 phases: initial survey, machining, then assembly and alignment. During this job, we used the Leica AT401 laser tracker and spatial analyzer software. Let's get into the review.
Let's skip ahead to creating a plane on our pin bore points. We want to graphically ensure our plane does not have a 3/4 or 1 inch offset that is often associated with laser tracker measurements. These are essentially on the plane, so we're good to go. Now we construct a frame on this plane. With this more meaningful coordinate system, we can look at our pin bore points and see that there's a little twist in this machine. Depending on tolerance and design of the particular equipment, we have to decide how to move on from here. Sometimes this is where we discover issues such as subsidence, which we can cover in another video. Now we're ready to set up our actual centerline coordinate system. These pin bore points are on lines parallel to the center line and equidistant to the center line. Regardless of angle, when we create a line between them, the midpoint of the new line is on the center line of the machine. Now we create a line between the pin bores on the other end of the machine. The center point of this end is located along this line in a defined distance from the reference plane on the side of the press. We can now construct a coordinate frame on the 2 center points with Z 90 degrees to the center plane around the x-axis. With our center line frame established, we move on to constructing the frames for our lower columns. One clocked -45 degrees around the X and one clocked positive 45 degrees around the X. We can now check the positions of the points we measured on the column. As you see here, point LRC10 is the lowest. During machining, we need to leave a 5mm shoulder at LRC10, so we create our target plane and move it 5mm below LRC10's location. Now let's look at the machining phase. To mount the milling machines rigidly, we use dimensions from the manufacturer's drawings and measurements we collected during a site walkdown to design these brackets. The brackets were welded to the press columns, then the milling machines were bolted to the brackets. We use a laser tracker to align everything to the press and dimensionally control the job. When the machining was completed, we assisted the customer with assembly and alignment of the press. Using the reference dimensions for the press, we created an alignment model. This model allowed us to quickly read the deviations of the component locations from their ideal locations, and in the end we were able to condense a 5-shift assembly and alignment down to 1 shift.
In future videos, we can expand on some of what we've covered here. Please leave your questions and comments below. If you have project challenges we can help you with, please feel free to give us a call or email us at info@tritonperforms.com. Thank you for watching.